So hello everyone, today we'll be discussing about a string based algorithm which is Manacher. So what exactly is this Manacher algorithm? It has two use cases. One thing is you can answer palindromic queries. You can answer palindromic queries. And the second use case is you can find the longest palindromic substring. You can find the actual substring as well as the length. Okay, so these are the use cases of Manacher algorithm. So it's a simple pre-compute based algorithm. It's a simple pre-compute based algorithm. It's a pre-compute for lengths of the strings. So let us get started. Okay, so what were the use cases? You were able to find palindromic queries. Like if you have L and R, you would be able to tell the substring starting from L ending at R is a palindrome or not. Okay, it's a palindrome or not. This is one use case. The second one was you were able to find longest palindromic substring using this algorithm. So this is already a popular lead code question, right? It's already a popular lead code question, isn't it? In this you used to follow something called expand from center, isn't it? Alright, you used to follow this expand from center. So the same principle we follow for this Manacher also, but in that lead code question, that particular question, if even length palindrome was given, this was supposed to be taken as center and you used to expand this way, right? This was how you used to expand. And if it was an odd length palindrome, you used to take this as center and expand. That's it, right? So in this way you used to find odd length and the even length palindromes in that particular lead code question. So in this Manacher algorithm also we are following the same concept of expand from center, but there's a problem here. If you want to do it in a single iteration to save some time, can I do it in a single iteration, both odd and even length? No, right? Because for even two characters would be the center, for odd one character would be the center. So this is the problem. So to solve this, can I somehow generalize this? Can I somehow generalize an odd length palindrome and an even length palindrome? So the answer is yes. How can I do it? Placing some empty characters. So let us say these dots are empty characters. Empty character is in the sense whatever the question you are given. If it's an alphanumeric string, any symbol like dollar, hash or dot would be an empty character because it's not present in that string, right? It won't be present in that string. So it's just an indicator that you have added it. Okay, if it's an alphanumeric string, in most cases it's alphanumeric, so it's always symbols. But let's say if it's an alphabetical string, you can take numbers or symbols as well. You can either take 1, 2, 3 if it's only an alphabetical string. Yeah, you can do these kind of things. And if it has some symbols, let's say a string has a hash 1, 2, 3. It can have numbers, it can have hash, it can have alphabets. Then you would say, then you take some other symbol as an empty character. So the moral of the story is all you need is an empty character to generalize it. How did it get generalized? If it's an odd length palindrome, it's still the same. B is the center. Okay, B would obviously match. Empty character match. A matches. Empty matches. So this is a palindrome. Coming to this one, the empty character is a center. B and B matches. empty empty matches, A matches, empty and empty character matches. Done. So in this way you made both odd and even into odd. This is an odd length, this is an odd length as well. So this is how you generalized it. Fine. Just a minute, I guess my mouse battery is over. Yeah, so that's how you generalized it. Okay, once after generalizing, you're supposed to do this expand from center, isn't it? So let's write the code for generalizing. Let's write string generalize. This would take const string ampersand s. Alright, const string ampersand s and string answer equal to, let's say, the initial character should be a hash, let's say, because if you somehow open a documentation like maybe any algorithms website or any blog, most often you would find this hash only. Okay, most people use this hash, so that's why I'm also using the same, but according to the use case you can change it. So to this answer, first you would add the character, then you would add the hash. Now we were supposed to expand from center, and this is supposed to be a pre-compute technique. So when I expand from center, what I'll be storing is the radius of the palindrome radius of the longest palindrome with center I. Alright, this is what I would be storing here. Where would I store this? In some radius of I, r of I. I would store this in some r of I. Alright, so let's make this r of I. Let's write a vector int Manacher. So this r of I is called the Manacher array, which you would use for other computations also. Like there were two use cases, right? To compute them you would use this Manacher array. Okay, so we have made this array named vector int r of size n comma 0, where n is the size of the modified string, the generalized string. So this s and this s is different. Okay, this is the original string which we are given, this is the generalized string after adding these hashes. So initially we have assumed that we haven't found any palindrome, so we would iterate over the centers. Alright, once after you iterate over centers, what you need to check, you are at a center, you should be checking the left and right. So while s of I plus p of I or r of I plus r of I is equal to I minus r of I. If this is true, r of I plus plus. If this is true, then r of I plus plus. Okay, what are we exactly checking? Initially, let's say there's some center B. Let's say there's some A, C. Let's say this is the case. Okay, for now forget about empty characters, it's an odd length palindrome, so it doesn't really matter if you have empty characters or not, the logic would still remain the same. So this is your I. What are you checking? What are you exactly checking? You're checking I minus p of I. What was p of I initially? P of I initially was 0. So I minus 0 and I plus 0, are they same or not? Obviously they are same, so p of I would go plus plus. Let's name it p of I because I'm habituated to writing p of I. Alright, so p of I. Fine. We are checking if I plus 0 and I minus 0 are the same characters or not. So obviously they are same. So what would happen? P of I would become 1. Now we are checking I minus 1, I plus 1. Are I minus 1 and I plus 1 same characters or not? Yes, they are same. Once again P of I plus plus. Now I minus 2, I plus 2. Are they same or not? Yes, they are same. P of I plus plus. I minus 3, I plus 3. Are they same or not? Yes, they are same. So once again P of I plus plus. Now next thing, are they same? They are not. So you would not do P of I plus plus and the loop would break. And we also need to check for bounds. So I plus P of I should be less than n and I minus P of I should be greater than or equal to 0. Done. P of I plus plus. With this is a simple computation. With this P of I would be calculated. But are we doing any kind of optimization here? Are we doing any kind of optimization here? It's still the same old lead code question type, like the brute force for it. It's still the expand from center. Are we doing any kind of optimization here? Not at all. We aren't doing any kind of optimization. Can we optimize? Yes. Can we optimize? Yes. What can we optimize? So if you're already inside a palindrome, like if you're ABAC, ABA, this is a palindrome, right? If at C, you already know this whole thing is a palindrome. When C was a center, you already know this whole thing was a palindrome. That means if I'm checking for this B, let's say if I'm checking for this B, somehow I reached from here to here, it reached B. I is currently at B. If I'm checking for this B, should I recompute again? This way? Should I do all this expand from center again from B? Not at all. I can check for this B, right? This B, the palindrome with center this B and this B is exactly the same, isn't it? Isn't it exactly the same? This is ABA, this is ABA as well. Are they both exactly the same? Even if I add those dead characters, are they exactly the same? They are exactly the same, right? They are exactly the same. There are a few edge cases for this. Which we'll look upon when do this particular computation fail. But first tell me, P of this thing, let's call it some J, is equal to P of J. P of I is equal to P of J. How can I reach to this J? I can apply some simple maths. To reach from here to J. I can apply some simple math, right? And what's that math? If center is here and my character is here, what would be the position of, like, if there was a center, if center was here, ABAC was here, what would be the position of this character? This is 2 into center, isn't it? 2 into center. Okay, so if C was here, it used to be 2 into center. The index used to be 2 into center, right? And 2 into center minus I. 2 into center minus I is what I need. So first let us declare this int center. Center is initially 0. And let us declare a variable farthest. Farthest is also equal to 0. So what I'm trying to do is, this farthest denotes how far the palindrome went from the center. So in this case, center is here, the palindrome went all the way till here. Okay, this is the farthest would be here, isn't it? So when can I say an index I lies between a bigger palindrome? Let's call it the grand palindrome. This is called the grand palindrome. When can I say I lies in the grand palindrome so that a mirror image would exist? When can I say this? it lies in the grand palindrome. If the I is less than the farthest, if I is less than farthest, farthest is already somewhere, it's at the end of the grand palindrome. If I is anywhere less than the farthest, then what I would do, I can simply do P of I is equal to, how can I compute J? How can I compute J? J is nothing but the mirror, right? Or else if I simply name it J, so the mirror image would be at 2 into center minus I, isn't it? But is it always true? Is it always true? If I take a palindrome A B A B A B A B C, if I take this particular palindrome, if this is the center, this is an odd length palindrome, isn't it? Forget about the empty characters because for easy computation. So A is the center, how far the palindrome is going? 1. B is the center, how far the palindrome is going? What's the radius of the palindrome? 1, 2. This A is the palindrome, A B A B A. This is a palindrome, so it's going till 1, 2, 3. And next, this B, A and A matches, so 1, 2. BB matches itself, 1. AA matches 2, BB matches 3, B and B matches 3, A and A also matches 4, so it's going till 4, B A B A, yeah, 4. And coming to this A, this A is part of a bigger palindrome, isn't it? This A is part of a bigger palindrome. So the mirror image length and this length would be the same, isn't it? The mirror image length and this length would be the same, isn't it? For this B is the center. This B is the center, isn't it? So if this B is the center, what's the farthest for this B? A matched, B matched, A and A matched. So yeah, this is the farthest. Beyond this limit, we don't know what are the characters. We don't know there's a B here, we don't know there's a C here. So far this is what we have explored. The farthest which we have explored is till here. So for this A, the mirror image is this A, and this A length is BB matches, AA matches, so it's 3. But let me tell you, if there wasn't a B here, let's say there was some X here, now this A is the mirror image, right? So for this A, BB matches and AA matches. Okay, so for this A it would work. Now for this B, what's the mirror image? This B is the mirror image and it's 2 here, so this thing matches. I guess this is a bad example. Let me tell you what I was trying to explain. Okay, so for this B is the mirror image. Sorry, for this B is the mirror image. It's 2, right? It's 2. So BB matches itself, AA matches itself. So this would work. And okay, just a minute. Let me think of a good example. A here, C here, B here, B here, A here. Yeah, this one. Okay, let's write for this 1. AA also matches, so this would be 2. BA, AA matches, BB matches, A matches, so 1, 2, 3. For this B matches. So how many matched? 3 matched. Yeah, Coming to this A, this is the center, this is the farthest, right? For this B, this was the farthest index that we have visited, like we have checked. This index is unknown. If I take this B, and the mirror image of this B is this B, right? If I simply take the mirror image of this B and place it here, that means this B would have a 2 here. But is it true? Is it true? Is the radius actually 2 for this B? No, it's not. If you observe here carefully, the next character is C, and C and A doesn't match. C and A doesn't match. They don't match, right? So we need to check. If I minus farthest, sorry, not I minus farthest, farthest minus I, farthest minus I is minimum, or the mirror image is minimum. Okay, if the mirror image is the minimum, this would happen. The previous example, this would happen. The mirror images would match. But if farthest minus I is the minimum, in that case, we don't know what's the unknown character here. So in that case, we are taking farthest minus I. So P of I equal to minimum of farthest minus I, comma, farthest minus I, and P of J, which is nothing but P of mirror image. Now this is fine. How do we compute this center and farthest? So how do we compute this center and farthest? It's very simple. If I plus P of I is greater than farthest, then update the center. Center would be I, and farthest would be I plus P of I. Fine. So this is how you are computing. Center and farthest. What are we trying to do? If your I plus P of I is greater than the farthest, then you are, till now the farthest was somewhere here, let's say. Okay, this was the palindrome, this was the center of that palindrome, this was the farthest of that palindrome. If any center in between, other center, gives you even more farthest, update the center, update the farthest. This is what you're doing. Fine. Till here the Manacher array calculation is completed. It's fairly completed. Now it's time for the use cases. What were the two use cases? First was palindromic queries in O of n. See, this is getting somehow amortized because of that mirror calculation. It's getting amortized. So coming to this palindromic queries, I need to answer the queries like is palindrome, and I would be given int L, int R, and some string S, isn't it? I would be given int L, int R, and a string S. Now I need to answer if it's a palindrome or not, right? I need to answer if it's a palindrome or not. So let's just take int L and R. Fine. So I have modified the string. By adding some hashes, if you remember properly, right? I have added hashes. So whatever the length it would return, it would be for the modified string. Can I somehow map the indices properly so that I get the original answer, like for the original string? Can I do that? So let us see how to map this indices. So if it's some ABA, original indices for this would be 0, 1, 2. So after this 0 1 2 3 4 5 6 0 1 2 3 4 5 6, this is what happened here. So if I want to map it to the original indices, 0 is getting shifted to 1, 0 is getting shifted to 1, the original index 0, let's write it as OG, and this is modified. OG0 is modified 1, and OG2 is, sorry, OG1 is modified 3, OG2 is modified 5, OG2 is modified 5. So what exactly is happening? Is it getting added to the length? Like it's 2 here. No, wait. What exactly is happening? Observe properly. 0 is getting to 1, 1 is getting to 3, 2 is getting to 5. Fine. So if I have L and R, L plus R by 2 would be the center for this, isn't it? L plus R by 2 would be the center, isn't it? Now if I have to map it to the original string, like the modified string, this is for the original string. If I want to map it for the modified string, after adding these hashes, so where would it be? Can I say that it would get multiplied by 2? Because for every character you are adding a character before and a character after. So can I say that this is 2 into 0 plus 1? This is 2 into 0 plus 1. This is 2 into 1 plus 1, 2 into 2 plus 1. So this would be 2 into L plus R by 2 plus 1. This would be the index of the center. So the center would be what was it? 2 into L plus R plus 1. It would be L plus R plus 1. L plus R plus 1. This would be the center. Now to check if it's a palindrome or not. How can I check if it's a palindrome or not? I just need to return if P of center is greater than or equal to the length. So if at this center, what are the palindrome radius is there, which is P of center. If L and R lies inside this, that means this length would be much smaller than this length, right? Or it could be equal. So this is what I am checking exactly. Okay, initially this would give error, no problem, because we haven't written that pre-compute thing. So let's write a method for pre-processing this. Let's write a void pre-process or pre-compute taking so let's take a string t, vector in p and a string t. So t is the modified string, t equal to build of s, and p equal to Manacher of, what was it, the method name, generalize Manacher of s. Done. The pre-computation is done, and we have written one of the applications, which is palindromic queries. The second application, what was the second application? The second application was supposed to be longest palindromic substring. Longest palindromic substring. So let's try to return the string first, then let's try to compute the length. Longest palindrome, const string ampersand, max length is equal to 0, int center equal to 0. If p of I is greater than the max length, then max length equal to p of I, and center would be equal to, center of the longest palindromic substring would be equal to I. And start would be equal to center minus max length divided by 2. Okay, this would be the substring, right? Now if I want to find the length, I can do the same process and find the length also. So finding length is a bit simpler. Longest length max of mx comma p of I. This would be the length. Done. What happened? Okay, fine. Now let's check if it's even working or not. I guess we don't need to pass string because we are doing it from the pre-compute. So alright, now it's time for queries. Let's take some queries. Q minus minus int LRC. For this we would require s because we are using s. So here we would pass this s also. Fine. So let's take some test cases. So what if I ask GPT to generate some test cases for us? Obviously we can use it for this. Looks like we have written some mistake. In pre-computed seeds. Yeah, Manacher on modified string. We need to apply Manacher on modified string. Okay, fine. Okay, so let's check it. It's saying C A B B A A B B A. But C, if C is included, it's not a palindrome, right? If C is included, it's not a palindrome. So what was the question again? It should be, yeah, this part should be a palindrome. So that means we should be, sorry, start plus 1. Done. Longest length would be this, and it's printing yes, no, yes, etc. etc. So this is working. So that's it for today, guys. Thank you, everyone.